So another thing we can do with recursion is to actually have a branch where we can call our recursive method more than once. And a good example of this is generating the Fibonacci sequence. Okay, so as a reminder, the Fibonacci sequence looks something like this. It's each term is the sum of the previous two terms. So 1 plus 1 is 2, 1 plus 2 is 3, 3 plus 2 is 5, 5 plus 3 is 8, so on and so forth. So we could write a function to do that. Okay, so we could work out the nth term. So if this is a 0 term, first term, second, third, fourth, so on and so forth, we could say nth Fibonacci number int n, and the definition of this is that the nth term of Fibonacci sequence is the sum of the n minus 1 term and the n minus 2 term. Okay, now obviously we need a way of exiting. So if the 0th term is 1, we can just return 1. But if we're above 1, if n is greater than 1, then what we can do is say, well, let's return the result of calling the nth Fibonacci number with n minus 1 and add on nth Fibonacci n minus 2. So if we try that out, okay, and we call nth Fibonacci number and we pass, say, 5 in, so 0, 1, 2, 3, 4, 5, we should get 8 out. So we say int result, and we can print out the result, and all being well, we should get a value of, so we've got an error here because we're getting a value of 16. So if we look carefully, the definition is the sum of the n minus 1 term and the n minus 2 term, but I've done n minus 1 and n minus 1. So let's run that again with n minus 2. And there we go, we're getting 8 out, which is what we would expect. Now, it's not necessarily a good way of solving this problem, because if you can imagine, for every version of for whichever number in the sequence we get, we are calling this method twice, which in turn will call the method twice again. So you can see the number of calls will quite rapidly go up. I mean, we could, just as an example, print out nth Fibonacci being called. Okay, we'll put that just before the return statement so it can actually execute. Well, in fact, actually, let's not even put it in there. We'll just put it in here. Okay, so we'll start off with a relatively low number. We'll look for the second. And you can see that gets called 3 times. Okay, let's just up that to the third number. And you can see that's now been called 5 times. Let's take it to the 4th number. Okay, and then we've got 3, 6, 9 calls. So you can see this grows pretty quickly. So as I say, it's not necessarily the way you would want to solve this problem, but it is an example of how it can be done. Yeah, so that's branching with recursion.